Hey, welcome to the video for Objective 3H. I will be able to find slope between 2 points when given the points, a graph of a line, or the equation, and I will be able to graph a line in slope-intercept form. So what is slope? Refers to the steepness of a line. We also talk about it being the rise over the run, so how far up over how far across, and it's also the change in y over the change in x. So we do have a formula for finding slope. It is this formula right here. Slope is, and we always see slope as m, and then it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, and this 2 and the 1 doesn't mean that you need to do the second point first here and then the first point. It doesn't matter which one you do first. You just need to be consistent in the order. So what I mean is, let me go ahead and set up my skeleton of my formula right here. But I need to start with the y's, so my y's, and just to remember or recall, this is x, this is y, this is x, this is y. So I'm going to choose whichever one to start with, A or B, that doesn't matter. And I'm going to go, okay, I need to do my y's on top, so I'm going to go y to y. Okay, so 6 to 7. And the reason I draw that arrow up there is to keep track that I went from this one to that one, because I have to go in the same order. I don't want to then go 10 minus 2. I need to go 2 minus 10. So 2 minus 10. And then I simplify this. If you decide to go this way, you would get the same answer. So 6 minus 7 is a negative 1. And 2 minus 10 is a negative 8, and I need to simplify this. I should either have one negative or no negatives, because the whole fraction's either negative or positive. If I have a negative divided by a negative, it's going to be a positive. So my slope between these 2 points is 1/8. If you did 10 minus 6 and 7 minus 2, you would also end up with 1/8. Okay, finding the slope when given a graph. So we're going to look at a few different graphs. So we have these two down here, but first we're going to talk about the slope of a horizontal line and the slope of a vertical line. And so remember, we've been using the acronym HOIVUX. Okay, so that zero part is now going to come in. So H, remember, is horizontal. So if I have a horizontal line, I'm going to go ahead and draw one in. And now let's pick some points on the line. Let's say that we've gone up 4. And we've gone over 1, 2, 3, 4. So this point I'm going to call negative 4, 4. And then this point over here, I can pick any point on here. So I'm just going to pick this point, which is 1, 4. Okay, so I'm going to show you that how we come up with the slope. If we're to use a slope formula here, so setting up my skeleton, and I do 4 minus 4, well, 4 minus 4 on top for the y, and then 1 minus a negative 4, 1 minus a negative 4, that's going to become plus. So be careful of that. I wanted to do this the long way so that way you can see that. And then 4 minus 4 is 0, and 4 plus 1 is 5, and 0 divided by 5 is 0. Okay, we can divide 0 by another number. So horizontal, the O in horizontal is actually a 0 for 0 slope. And then the equation looks like y equals something. And in this case, it would be y equals 4, because it goes through 4 on the y-axis. All right, so the slope of a vertical line, how do we get that? Well, let's actually find it with the points. But know that normally if you see a horizontal line and you know for sure it's horizontal, you can just say 0 slope. But I want to show you why it is 0 slope. All right, so vertical line. Here's a vertical line. Let's go ahead and write vertical for V. And we're going to call this 2, and I'm going to just pick any point on the line. I'm just picking any point to show you what happens when I use the slope formula. So this point would be 2, 3. And I'm going to use this point, which would be negative 1. Sorry, it would not be negative 1. It would be 2, negative 1. Right? We have a vertical line, so my x's have to be the same. So 2, negative 1. And then I'm going to use the slope formula and find out what the slope is going to be. So I'm going to do my y's first. I'm going to start with this one, so I'm going to go in this direction. So 3 minus a negative 1 makes it plus 1, and 2 minus 2. So 2 minus 2. Well, 3 plus 1 is 4. 2 minus 2 is 0. And as we've recently discussed, we cannot divide by a 0. This is called undefined. No zeros on the bottom. Undefined. So coming back here, the Vux u is an undefined slope, and that's where it comes from. And then our equation is x equals, and in this case, it is x equals 2 since it goes through the 2 on the x-axis there. All right, so that covers vertical and horizontal lines, but what about when we actually do have a slope going on here? So we have a steepness that we can see. An increasing slope is going to be a positive number when we find that slope. And increasing means that it's going uphill from left to right. Uphill, you can write left to right if you need that. I think because we read left to right, that probably sticks in our head. And then when you're trying to figure out the slope, I'm always asked, well, which point do I start from? It doesn't matter. You just need to keep track of your negatives. Or you don't need to keep track of your negatives if you know that when you're going uphill, it's positive. Okay, so what that means is, let's figure out, we could use the formula. We could find out what these points are and then just use the formula, or we can just count off from the graph, which I kind of think is easier. So rise over run. So we're looking how far does it go up or down over how far does it go left or right. So I can go from this point to this point, and I go, okay, I'm going down 1. So down is moving in the negative direction. And I'm going left 2. So also negative. And then I would just need to simplify this. A negative divided by a negative is a positive. You can also go from this point to that point. Doesn't matter. You're going to get the same answer. So if I go from here, well, now I'm going up 1, and that's positive, and I'm going right 2, and that is also positive. So either way, you need to be careful of your negatives, or you just know that it's going to be positive. So you can just count your boxes and figure out the negatives at the end. But our slope for this picture here is 1/2. All right, coming over to here, decreasing slope is going to be negative, and it's going to go downhill. So it goes downhill. And once again, we're just going to count, rise over run. Doesn't matter which dot you start from. So I'm just going to start from this one, and it looks like I'm going over 2 in the positive direction, and then I have to go down 2. So going down is negative. And then I'm going to simplify this. Well, 2 divided by 2 is negative 1. Okay, let's flip it over. Okay, so now we're going to get into another way of plotting a linear equation. So far we've been making a whole bunch of tables to plot linear equations. And then we looked at parent functions. So we looked at a bunch of different equations. So our basic linear equation is just y equals x. So I'm going to draw that in. What does y equals x look like? Well, y equals x is just the line that goes diagonally through the graph, right? Goes right through the origin, goes right through this spot right here, and has a slope. Well, since nothing's in front there, it has a slope of 1, and that makes sense with our picture, 1 over 1, 1 over 1, 1 over 1. So we have a slope of 1 for this one, and we're starting at 0 here. Okay, so what does this do? Well, if you recall, when we were talking about finding patterns in our basic graphs, when we added a number to the outside, so it wasn't inside the equation, well, if I add a number to the outside, it moves it up. So in this case, this is also going to move this line up. So I'm going to then draw my new line right here. So this equation, actually, let me write this down. This equation here is y equals x. This new equation that I'm going to plot, the y-intercept is right here. So the first thing you need to do to plot this is plot the y-intercept, which is this guy out here. All right, then the second thing you need to do is use the slope to find the steepness of the line. Okay, so actually when you're multiplying inside of an equation, we talk about stretching or shrinking the line. So that you'll get into deeper someday in your math classes, but really what this is we're going to plot the slope to show the steepness of this line. So we're going to count the slope. Rise over run. From the y-intercept. And that's important because over the years, I see a lot of people making the mistake of counting from the origin. So they plot this dot, and then they count from the origin the slope. Well, no, we're going to plot this dot and then start here and count the slope. So we're going to find out what the rise is. Well, the rise is 1. So I'm going to go up 1, and then I'm going to go over 2. And since both of those are positive, I'm going up in the positive direction and over 2 in the positive direction. So now I have 2 points, and 2 points is what it's going to take to plot this line. Now I just need to actually connect my 2 points. There we go. I'm going to stretch mine out. Make sure that a couple things about your line has to go to the edge of the coordinate plane. We don't want these little tiny lines. And it also should have arrows on the end. That's very important because we're showing that these are lines that go on forever. So this one that we just drew in, this is the graph of 1/2 x plus 2. Okay, so just 2 steps here, or I guess the third step would be to connect the 2 points that you drew with the line. So let's make that third step. Okay, so this part right here is the slope, and this is part of your objectives for this, is that you want to be able to recognize the slope in the equation. So the slope is the number in front of the x, okay? So coming over here, well, you might think, well, then the slope is the number in front of the x here. Well, that's not true. The slope can only be found in front of the x when the equation is in point slope form. Okay, so make sure that you get this down, and also make sure you get down what does point slope form look like? Well, it looks like this right here. Okay, notice how this was in point slope form. We had the slope, which I already told you is m, and then we have the y-intercept, which is b. So we want to make sure it's in that form. So when it's not in that form, we are going to have to first put it in that form by solving for y, and that's why we spend some time rearranging equations and getting the y by itself. Okay, so I'm going to take this equation that we're supposed to graph here, 2x plus 3y equals 7, and I'm going to solve for y. So first thing I'm going to do is subtract 2x. They disappear from over here, and I'm left with 3y equals, and now I need to combine these. And I've talked about before how I like to put this x term first, because then that's how we're going to end up with it in point slope form. So negative 2x plus 7. Then I'm going to divide by 3. And I need to divide everything over here by 3. So that means that negative 2x, the negative 2 is going to be over 3. And then my 7 is also going to be over 3. And I am going to divide it up like that because I need to make sure that I'm finding the slope. All right, so coming back over here, I'm just going to use these 3 steps. Plot the y-intercept. So here we go. Here's our y-intercept. Now you might be thinking, well, how do I plot 7 over 3? Well, it is tricky like this, so we're going to have to rewrite this as a mixed number. Okay, so this is one of the hardest ones that you could see plotting, where you end up with a y-intercept of a fraction, but it's always nice to see the hardest one. So this part stays the same, but this I want to change into a mixed fraction. 3 goes into 7 2 times, and what's left over is 1/3. All right, now I can plot that y-intercept. So plot the y-intercept. This is the y-intercept. So I'm going on the y-axis to positive 2 1/3. So 1, 2, and then I'm going to kind of eyeball it and call that 1/3. Okay, next, that almost looks more like 1/2, but with these tiny little squares, it's hard to get much better than that. So 2 1/3. There we go. Still pretty close to 1/2. That's all right. Most of the time, you're going to have a non-fraction there for the y-intercept, but we do want to look at what happens when it's not that situation. All right, count the slope, rise over run from the y-intercept. So now I have a negative 2/3, and you can use the negative on the top or on the bottom. Just don't use them for both. Don't make them both negative. So if I say this is negative 2/3, I'm going to go negative 1, 2, so this direction, and then I'm going to go up 3. So I'm going to the next spot that's a third, and the next spot that's a third, and the next spot that's a third. That would be negative 2/3. And then to double check, I want to make sure that when I connect these, I'm going to have a negative slope, and I am. You could have gone positive 2 and negative 3, that's fine too. So positive 2, 1, 2, and then negative 1, 2, 3. And all of these are going to fall on the same line. Okay, that's it. That's it for my part of this video. You're going to now want to find the slope of the line containing the given points. So use the slope formula. It's on the front. Find the slope of a line. So now you're going to count off. Be sure to check whether you think it should be a positive or negative slope. And then last one here, see if you can graph a line. We'll definitely practice this skill in class, but see what you can come up with. So make sure that you're following the steps above. All right, thanks for watching.